So this is problem 4-4 for mechanics, and part A asks determine the cart's average acceleration between time 0.33 seconds and time 0.37 seconds. And so we're given the velocity versus time graph, and as you know, acceleration is the derivative of velocity, and what that means is just find the slope from 0.33 seconds to 0.37 seconds. And so this is my slope formula right here. So this is just from the best fit line of the graph. My numbers might be different from yours. It doesn't really matter since this is a lab question. And so I used the slope formula and got a negative acceleration of negative 10.25 meters per second squared. And so moving on to part B, it asks, determine the magnitude of the change in the cart's momentum during the collision. So the change in the cart's momentum is just delta p, but we also have to take into consideration that delta p is equal to the integral of force dot dt, which is just impulse, and delta p equals, so what we do is we just take the area of the force graph from 0.33 seconds to 0.37 seconds, so just the area of that mountain you see on there, and you get 0.6 newtons seconds. And so the change in momentum is 0.6 kilograms times meter over seconds. And moving on to part C, it asks you determine the mass of the cart. And mass of the cart, you can just find that out by using the change in momentum equation. So change in momentum is equal to mass times the change in velocity, because mass can never change, it always stays the same, and velocity only changes. So mass will be equal to the change in momentum over the change in velocity. And so change in momentum is 0.6 times Newton seconds, and change in velocity is 0.4 meters per second. And you get a mass of 1.5 kilograms. And the answer to part B, again, was 0.6, and the answer to part A was negative 10.25 meters per second squared. Moving on to part D, it asks you to find the energy lost in the collision between the force sensor and the cart. So you just have to find the energy lost between 0.33 seconds and 0.37 seconds. And we can just use the law of conservation for energy. So 1/2 mv squared at t equals 0.37 seconds has to equal, subtracted, you subtract 1/2 mv squared t equals 0.33 seconds, and you get your energy, change in energy. So the velocity at 0.37 seconds is 1/2 times the mass, which is, going back to part C, the mass was 1.5, and the velocity was negative 0.18 meters per second squared, and you subtract that from 1/2, 1.5, and the velocity at 0.33 seconds was 0.23 squared. And these are the velocities that I used for my analysis of the best fit line. And so when we calculate this, we get 1 second, please.
India is the highest player efficiency rating.
So we get 0.0243 for this, and then we get, 1 second, almost done. And you get 0.039675, and you get negative 0.015375 change in energy, and that's the answer for part D. The energy lost is this. That's the answer.